In this exercise, we're asked to graph the function f of x equals the square root of x. What you'll find fairly soon is that this is known as the square root function, which is fairly intuitive since it's taking the square root of x. The process for graphing is essentially the same. It helps to start with a little bit of base knowledge that since we're taking the square root, x can't be negative. If we put a negative number in for x, we'll get something that's not defined in the real number system. And therefore we can't use any negative numbers. Also, since we're taking the square root, it makes sense to put in inputs that are perfect squares. So when we take the square root, we get a whole number value. So we'll start with x equals 0. So f of 0 equals the square root of 0, which equals 0. Our next x value is f of 1. X equals 1, which equals the square root of 1, which equals 1. X equals 4 equals the square root of 4, which equals 2. And last, x equals 9. F of 9 equals the square root of 9, which equals 3. So when x equals 0, f of x equals 0. When x equals 1, f of x equals 1. When x equals 4, f of x equals 2. And when x equals 9, f of x equals 3. That yields the points 0, 0, 1, 1, 4, 2, and 9, 3. So we plot those points. 0, 0, 1, 1, 4, 1, 2, 3, 4, 2, 1, 2, and 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. 1, 2, 3. Connect the dots with a smooth curve. And this is the graph for f of x equals the square root of x. And as you can see from this, up to this point, we've looked at functions where the domain was all real numbers. The range sometimes was limited. With it being squared, we'd never have a negative value. In this case, since we're taking the square root, it's both those restrictions. So we can see from this graph that the domain, it can be 0, because the square root of 0 is 0, but then it goes on infinitely in the positive direction. And the range, again, that can be 0, and it goes up infinitely to infinity as well. So both the domain and range are 0 infinity with this function.